All right, it is time for standard 4. So we're going to be simplifying and evaluating. So problem number 1 here, we've got a fraction here divided by a fraction. You don't divide fractions. What we are going to do here, though, is we're going to factor the first part. All right, so let's see, minus 3x plus 2, and then 2 minus x. Now, we don't divide. We're going to turn this into multiplication, and I am going to flip this fraction over. So the 2x minus 6 is going to become the numerator, and the x squared minus 4 will become the denominator. And I'm going to factor as I go. So 2 times x minus 3, and then x minus 2x plus 2. So let's see what we got here. X plus 2, x plus 2. And yeah, that's it. There's nothing else you can cancel out. So you're just going to write down what you have left over. So x minus 3 happens to be squared because there are, let's see, 2 of them here. I need to also include that 2 in the numerator. And then in the denominator, I've got 2 minus x and x minus 2. All right, that is it for problem number 1. Let's roll on over to number 2 here. Again, simplification. This one's already a multiplication problem. So factor some more. And when you're sick of factoring, try and factor again. All right, so 2x and x. You pick your factoring method. Let's see what we can do here. Plus 3 minus 2, x plus 5, x minus 1, x minus plus 4, x minus 4, difference perfect squares, and then 3, that's a horrible 3, 3 times x plus 4. All right, let's see what we can do here. So we've got x minus 1, x plus 4, x plus 4, and I think that's, oh wow, I can't multiply. All right, I was thinking in my head, it was trying to multiply to 5 and add to 4. Reverse that. I'm trying to multiply to positive 4 and add up to a negative 5. So that should be a negative 4. That makes a little bit more sense. So for anybody yelling at the screen going, what are you doing? I'm making a mistake is what I was doing. All right, so let me take again. Multiplying to positive 4, negative 4 times negative 1, that works. And then adding up to negative 5, yeah, that works. Okay, my apologies. Now I can cancel those out and simply write down what was left over, which is going to be 2x plus 3 all over 3. And no, for the love of all that is good in your math world, you cannot cancel those. All right, you have to cancel out entire factors, and unfortunately that 2x plus 3 is a factor joined together. All right, so let's see if I can get through problem number 3 without too many screw-ups. 8 and 16, and this we're dividing here, so this is going to be all about bases. I need a base of 2. So 2 to the 3rd is going to be our 8. And then we've got 3x minus 4. 2 to the 4th is our 16, x minus 1. So this is 2 to the 9x minus 12, all over 2 to the 4x minus 4. And what we're going to do now is we're going to subtract those exponents. So 9x minus 4x is 5x, and then be real careful. Negative 12 minus negative 4 is the same thing as negative 12 plus 4, so that's going to be negative 8. And that is the simplified form for number 3. Nothing else we can do there. I'm not asking you to solve these. All right, problem number 4 is almost the exact same thing as problem number 3. This time we're changing a few things. We've got base 2, base 4, base 16, and base 8. All of them need to be written as a base 2. So 2 to the 5x plus 3 isn't going to change. 2 squared is my 4. Let's see, 2 to the 4th is my 16. Whoops, 3x. And then 2 to the 3rd is my 8. All right. So let's clean up this mess. So 2 to the 5x plus 3, times 2 to the 2x minus 2 times 2 to the 20 minus 12x all over 2 to the 3x. All right, in the numerator, I'm going to add up all of my exponents. So I've got, let's see, 5x plus 2x is 7x. 7x minus 12x would be negative 5x. Let's see, 3 minus 2 is 1. 1 plus a 20 would be positive 21, all over 2 to the 3x. And then last one is quotient rule. We're going to subtract those. And so I've got negative 5x minus 3x. It's going to be negative 8x and then positive 21. I think my handwriting gets larger the closer I get to the end of the problem. So that's the end of number 4 here. Number 5, I'm asking you to divide complex numbers. So what we're going to do is we are going to multiply by the conjugate of that complex number. Fully distributed across the top, that's going to be 8 minus 4i minus 6i plus 3i squared. Fully distributed across the bottom, 4 minus 2i plus 2i minus I squared. Please do not forget that I squared is equal to negative 1. All right, by definition. So this part right here, positive 3i squared is going to be actually negative 3. And then negative I squared is actually positive 1. Negative 2 and positive 2i will cancel each other out. So 8 minus 3 is going to be 5. Negative 4i minus 6i is negative 10i. And then 4 plus 1 is 5 in the denominator. So 1 minus 2i. Simplified completely. All right, problem number 6. All right, we're still dealing with i's. The only one we're going to need to worry about is I squared again. Let me actually write that a little bit more clearly. So I squared is going to equal negative 1. So fully multiplying out 4 plus I squared, it's going to be 16 plus 8i plus I squared plus 2i squared minus 7i plus 1. Combining some like terms here, we've got 6. Actually, let me do the i's first. So I squared here is going to be negative 1 minus 2, because the I squared here would become negative 1. Okay, so I've got 16 minus 1 minus 2 plus 1. So I'm pretty sure that's 14. And then 8i minus 7i is just going to be plus I or plus 1i. All right. Keeping on rolling on here. It says to find the sum. So we've got to do 1, 2, 3, and 4. That's your start. That's your end. Okay. And for each one of these, I'm going to replace x squared with, or x with whatever x is equal to. So 3 times 1, 2 times 2 squared minus 3 times 2. 2 times 3 squared minus 3 times 3. And 2 times 4 squared minus 3 times 4. Hey, there's my calculator. All right. So 2 times 1 squared minus 3 times 1 is negative 1. And then I want to do the exact same thing. So 2 times 2 squared minus 3 times 2. That's 2. 2 times 3 squared, close the parentheses, minus 3 times 3 is 9. And 2 times 4 squared minus 3, 3 times 4, not minus, times 4, and that's 20. So if I add up negative 1 plus 2 plus 9 plus 20, I know I said it, apparently I'm having issues writing today. All right, that is going to be a sum of 30 there. And I have another summation problem. So let's find the sum. Same kind of situation. We're going to start with 1, 2. We're only going to end at 3, though. All right, so 1, 2, 3. And for each one of these, let's do 4 minus 2 to the first, 4 minus 2 to the second, and then 4 minus 2 cubed. That's going to be 2. That's going to be 0. That's going to be negative 4. Those I could actually do in my head. Good thing my Apple Pencil's dying is that horrible death. I assume you saw the notification. So 2 plus 0 plus negative 4 is going to equal negative 2. All right, I'm going to keep on rolling on down into the next page, see what I can get through here. All right, so for this particular problem, I want to start with what's inside the parentheses, which is going to reference diamond here. So negative 1 diamond 2, going to be 2 times negative 1 times 2. That's negative 4. So then we're going to do 4 arrow negative 4. So 2 times 4 minus 3 times negative 4 squared. So 8 minus 48. Sure. Yeah, that sounds good. And that's going to be negative 40. I had to make the brain work. I have a calculator handy, but apparently I'm just not going to use it today. All right, so then I want to do the next one. So I got to start with little rectangle-y rhombus looking thing. And that's going to be 2 and then 6. So this is 6 squared, which is 36. Then I'm going to do 36 circle 5. So 36 circle 5. So 3. All right, slow down. 3 times 5 minus 36. So 15 minus 36. Don't feel like thinking. So 15 minus 36. I got negative 21 here. All right, so I'm going to keep on rolling because I think this last part, got a couple more sections here. All right, so let's see. We've got g of a plus 2. So I'm going to reference the g function, and everywhere I have an x, I'm going to replace it with a plus 2. So that's going to be a plus 2 squared plus 3 times a plus 2. So a squared plus 4a plus 4 plus 3a plus 6. Just simplifying as I go. Plus 7a plus 10. No, I do not know what a is, and no, you're not going to be able to figure out what a is. Let's see, k of 2 minus 3x. So k function here, everywhere I have an x, and there's 2 of them, I'm going to replace it with 2 minus 3x. So that's going to be 2 minus 3x minus 1, and 2 minus 3x plus 3. So negative 3x plus 1 over negative 3x plus 5. I'm content with that. And no, again, you cannot cancel those out because you have to be able to cancel out an entire factor. And those are terms. All right. All right. So we've got f of g of negative 4. So the first thing we're going to do is g of negative 4. And that is, let me go find my g function here, x squared plus 3x. So x squared plus 3x. Replace with negative 4 and negative 4. So make the calculator do the work. Negative 4 squared plus 3 times negative 4 is 4. All right, so then we're going to do f of 4. So let me go find the f function. Now this is the piecewise function here, and you have 2 pieces. Either x is less than 0 or x is greater than or equal to 0. Now x was 4. That's greater than or equal to 0, so we're going to use this piece of the puzzle. So x squared minus 6x, x squared minus 6x, and each of those 4s. So 4 squared minus 6 times 4, negative 8 is your final answer there. Let's see, k of h of x minus 1. So looks like this, which means I'm going to start with this set. So I want to do h of x minus 1. So let's go find the h function. 3x plus 2. So 3x plus 2, and x is going to replace with x minus 1. So 3x minus 3, whoops, write the x. 3x minus 3 plus 2. So 3x minus 1. And that's then going to become k of 3x minus 1. And so let's see the k function. All right, so this is my fabulous fraction here. So x minus 1, x plus 3. X minus 1, x plus 3. And each of those x's gets replaced with 3x minus 1. And I'm going to simplify. So let's see what we got here. So 3x minus 1 would be 3x minus 2. And then 3x minus 1 plus 3 would be 3x plus 2. Nope, no idea what x is. Not going to worry about it. All right, last set for standard 4 is using the properties of logs to condense and expand. So the first thing I want to look for in the properties when I'm condensing is, do I have any nifty little exponents that I need to fly up? And I do. It's going to be the natural log of 4 plus the natural log of x to the 5th plus the natural log of y to the 6th. And all of these are addition. So let's go ahead and write this as a single multiplication problem. So 4x to the 5th, y to the 6th. All right, that is condensed. Problem number 15, let's do some exponent flights. So that 3 flies, the 2 flies, the 7 flies. So this is going to be log of x cubed plus log of y squared minus log of z to the 7th. The ones that are being added create a multiplication problem. So this is going to be log of x cubed y squared. And then the one that we're going to subtract here becomes the denominator for our expression. So x cubed y squared over z to the 7th. And I will highlight that one as my final answer. And then for problem number 17, we're going to reverse it. So the first thing I'm going to do is split the division. So the natural log of 3x squared minus the natural log of 4. I'm going to split on the multiplication. So the natural log of 3 plus the natural log of x squared minus the natural log of 4. And the last thing I'm going to do is fly the exponent. So natural log of 3 plus 2 the natural log 2 times the natural log of x minus the natural log of 4. And I'm almost done. Number 18, we're going to split. Whoops, apparently I'm going to hit the wrong thing. Split on the multiplication, split on the multiplication. So this is going to be log of 2 plus the log of x to the 4th plus the log of a to the 5th. I'm going to fly the exponents, and I will then be done with this problem. So log of 2 plus 4 log x plus 5 log a. And ta-da! That is standard 4. Please let me know if you have any questions or concerns, and I'll make a separate one for 5 and 7.